we have understood till now how to find the resultant vector using graphical method. Now let's start off with our analytical method. To begin with, we have something called as cosine rule. So the pre-requirement for this is magnitude of a vector and the angle between them. Now let us have a small animation to help us understand how to derive this. So the pre-requirement being the magnitude of the vector, as you can see, and the angle between them. Remember, when we talk about angle between vectors, it is always when the vectors start off from a common point. It's very important to understand this, because in numericals, the angles that is given, that might be confusing. They might give you some other angle, and you might end up you have to find some other angle, so on and so forth. So there is some kind of confusion over there. So for that, the best thing is learn one thing properly. What does the angle of a vector mean? Using that knowledge, we'll be able to resolve any issue. Okay, so the derivation starts off with shifting the angle and the vector itself, okay, along the line of the first vector. Then finding the projection of the vector b onto x and y axis. It would be something like this, right? So what does projection mean? So we have seen this. We should be knowing all of this. So we have the first vector. We have the second vector. Then we are looking at projecting onto the x-axis and the y-axis, thus making this as 90 degree. Now, so this would be b and this is theta. So we have a triangle. This is a right angle triangle. We know one angle, we know one side. How can I find the base and the height? Yes, this is where we use trigonometry. So this is b, correct, cos theta, and this is b sine theta, right? Now, where is the resultant vector? Well, it's over there, starting from the tail of the first vector to the head of the second vector. Now we have to figure out r. This would be our resultant vector. So we have to figure out this r. How will we figure out this? So this being a and this being r and this being b cos theta sine theta. So basically we are looking at, yes, a right angle triangle. This is r. This is a plus b cos theta. This is 90 degree and this is b sine theta. Again, we're just adding up the length, right? A and b cos theta. In entirety, it's a plus b cos theta. Now, how do you find r? So this, so you would be answering a plus b cos theta the whole square plus b square sine square theta. Again, you have to be very thorough with trigonometry moving forward. And of course, math basics. So I'm expanding this as a plus b, a square plus b square plus 2ab cos theta. Then this would be plus b square sine square theta. That's the other term which is left. Now, between this two, b square is common. So we have a square plus b square, that is common. So this is cos square theta plus sine square theta plus 2ab cos of theta. Now, cos square theta plus sine square theta is equal to 1, that you guys know. So your answer ends up being this. Agree? There's a bit of twist. So I told you there's another angle that we might end up using, and that being the following. Something called as beta. Okay, as you can see, theta and beta have a certain relationship. What is it? Yes, beta plus theta adds up to 180 degree. So the next variation over here is that we have theta which is equal to 180 degree minus beta. So my question to you guys is, I don't know if you have studied this as of now, as of today, but you will be studying this if you're not. In place of theta, if I put 180 minus beta, so this would be equal to what? This would be equal to minus cos of beta. Okay, this you will be learning in trigonometry, right guys? So let me not go to the details of this. So your other important result is r square is equal to a square plus b square minus 2ab cos beta. So depending on the angle, you have to use first or the second expression. So that's where I told, be clear with what is the angle between the vectors. So to summarize, we have the diagram, we have what is theta and what is beta. Theta will describe it as angle between the vectors from when they originate from the same point. And that's what we saw from the graph initially. While beta is the angle opposite to the resulting vector. Okay. So this is r and beta is opposite to the resulting vector. If I consider a triangle, this red, blue and green triangle. So you guys can write down what is the magnitude, you yourself. Anyways, you guys have seen all of that. So fill this up. And finally, let's talk about the angle. See, let's call this as beta, alpha first. This is alpha. How do you figure out? Oh, I was able to give the answer away. How do you figure out alpha? Again, let's make use of this right angle triangle. We have the base and the height that is known. We have to find an angle. So we will figure out tan of alpha. Again, remember, r is something that it's an unknown. Of course, after finding that will be known and you can use that also. But if you don't know r, if you just know the vectors, how do you find it? Using the following formula, opposite by adjacent. It's a simple, straightforward formula. That's it. Right? Very simple. The only confusing part is alpha, theta and beta, the angles. So I'm calling this as theta, this is beta, so on and so forth. Made it very clear in my derivation. So don't miss anything. Please copy everything.